Well, welcome to this video on Newton's second law of motion. Question, what do you call a chicken crossing the road? You might call it poultry in motion. Since we're talking about motion, I figured you wanted a motion-related pun to start off with. Okay, so what are we doing here? In this video, we're going to describe the relationship between mass and acceleration given the same force. And then we're going to calculate force, mass, and acceleration, and also weight using Newton's second law of motion. So what is Newton's second law of motion? Well, it says that the acceleration of an object depends on the net force acting on it and the object's mass. So acceleration of an object depends on the net force acting on it and the object's mass. And here it is. It's math, but it's simple math, right? So force is mass times acceleration. Force is mass times acceleration. This is a very important formula to know, to have available in your notes for when you need it. So we would abbreviate this F equals ma, m times a, mass times acceleration. When we put two letters next to each other like that, we mean multiplication. And of course, let's remember our units. Force is measured in newtons in the metric system, capital N for newtons. Mass is measured in grams, although to make the units work properly here, we usually want to use kilograms. And then acceleration is measured in meters per second squared. Meters per second squared. So those are your units. And let's see how to do problems using Newton's second law of motion. So imagine we've got this car. Its mass is 1,000 kilograms, and it's going to accelerate at 4 meters per second squared. So what is the force required to do that acceleration? Well, let's take a look. Remember to write down our formula. Force equals mass times acceleration. Fill in the things that we know. Mass is 1,000 kilograms. Acceleration is 4 meters per second squared. And so the force is those two things multiplied by each other. 1,000 times 4 is 4,000. The units also multiply, so it becomes kilograms times meters per second squared. And hopefully you remember kilogram times meters per second squared is the same thing as a newton. So the answer is 4,000 newtons. 4,000 newtons will accelerate the car 4 meters per second squared if that car has a mass of 1,000 kilograms. Okay, let's talk about weight. What is weight? Well, weight is simply a force. Weight is a measure of the force of gravity on an object, and it's a product. It's the product of the object's mass and the acceleration due to gravity of the planet it is on. And on Earth, acceleration due to gravity is 9.8 meters per second squared. And that's a number to know, right? We abbreviate it with a small g. That's a number to know, 9.8 meters per second squared. Every object that is within the gravitational pull of Earth is accelerating towards the center of the Earth at 9.8 meters per second squared. Even right now you are doing that. It's just that there is an equal and opposite force preventing you from moving anywhere. But if you drop an object, it is going to change its velocity at 9.8 meters per second squared as it falls towards the ground. And the formula for weight is basically the same exact thing as the formula for force, just substituting two different things in here. So for force, we say weight. Remember, weight is a force. We've got our mass, and then for acceleration, we have the specific acceleration, the acceleration due to gravity, which is little g. So the formula for weight is mass times gravity. Weight is mass times gravity. Here's an example. The Apollo lunar lander, the craft that reached the surface of the moon, had a mass of 15,200 kilograms on, 15,200 kilograms. What was its weight on Earth, and what was its weight on the moon? Notice I did not give you g for Earth, because you should have that written down already, but I did give you a g for the moon. So on the moon, things accelerate towards the center of the moon at a rate of 1.6 meters per second squared, so much smaller than that on Earth. So here's our calculations. Again, our formula is weight is mass times gravity. Weight is mass times gravity. So I just use Earth as this little subscript to say that here I want to calculate on Earth, it's 15,200 kilograms times 9.8 meters per second squared, and that's going to give us 148,960 newtons. We do the same thing for the moon, weight on the moon, same mass, but instead we multiply it by the gravitational acceleration on the moon, which is 1.6 meters per second squared, and that should give us 24,320 newtons. So a lot less, as you can see, a lot less on the moon. Now back to our good friend, the Space Launch System rocket. So the Space Launch System weighs 25.7 million newtons on Earth. What is its mass? So that's its number of newtons, right? That's its weight. We want to calculate its mass. So again, weight is mass times gravity. Here is the weight in newtons, 25,700,000. And that is equal to m times 9.8 meters per second squared. So to solve for m, we have to divide both sides by 9.8. Divide both sides by 9.8. So m is equal to 25,700,000 newtons divided by 9.8 meters per second squared, and that is equal to about 2.6 million kilograms. About 2.6 million kilograms. So those are weight calculations, force calculations. It is actually fairly straightforward math. But don't forget to always stop and make sure you're getting it correctly. Take your time as you do these problems. See you in the next video.